Hi, today we are talking about the replication. So coming to the replication, so Watson Crick is a founders of DNA. So he discovered the Watson and Crick DNA. So interaction beside the maintaining the integrity of success sequence by the DNA repairs, all organisms must duplicate and accurately before the every cell divisions. So DNA replications occur at polymerization rates of the about 500 nucleotides per seconds in bacteria and 50 nucleotides per seconds in mammalians. So replication will occurs always is 5 prime to 3 prime. So it is not 3 prime to 5 prime. Replication is always occurred in 5 prime to 3 prime direction only. Replication is simultaneous. So that means simultaneous both side will be occurred. Replication also is bidirectional. We majorly observe here replication is bidirectional. It obeys the base pair rules. Also replication results in two daughter DNAs, one from the parent and another from the complementary DNA strands synthesized newly. Hence this replication is semi-conservative, held by the phosphodiester bonds and hydrogen bonds. So what are the cell cycle? So cell cycle is a sequence event that occur in a cell during the cell division. It results in formations of two identical daughter cells. Duration of cell cycle varies from cell to cell. It occurs majorly four phases. Those are the G1 and S phase, then G2, finally M phase. G1 is gap 1 phase and S is synthetic phase, and G2 is the gap 2 phase and mitotic phase. So this is the here is gap 2 phase and gap 1 phase, and the S is synthesis phase. So first of all we'll see about the G1 phase. So like a preparative phase for the DNA synthesis. All cellular components of replicated exact DNA cell size increases. Any damage of DNA detected. Synthesis phase will be replication will be occur. Where the occurred in replication, the synthesis phase. This synthesis phase will DNA replication will be taken place. They take that place. So G2 phase, it prepare the cell division and spindle formation. Any DNA damage, DNA is detected. M phase is mitotic phase. Mitotic phase multiplication, like a cell undergoes the cell division. It includes perhaps metaphase, prophase, metaphase, anaphase, and telophase. After the mitosis, cell may continue cell by re-entering into G1 or enter G0 phase, remain the dormant or leads to cell death. So this is the phase how DNA is in the replications and also mitosis, and this is due to cell division phase, and this is the growth phase and metabolism here. Simultaneously it will go, some case it is non-avoiding it due to cell death. This is apoptosis. So models of replication, we first of all will say that what are the different types of models. So here we will see about the conservative and semi-conservative and disparative models. There are the three types of models. Here we will see the semi-conservative means bidirectional is one from parent, another one is complementary DNA. Here is conservative model. Conservative is completely one, and here double strand will be synthesized apparently. It is completely first generation. He is completely from newly synthesized. Here is some mixing here, that is disparative model. This disparative model will be here, we can observe easily dispersion, like a small will be accurate these things. So semi-conservative, here we will see about what are the models of semi-conservative. Here is some DNA cesium chloride procedure will be following here. This procedure will see in the first phase and second phase. The increasing density of first, like DNA is light band and a heavy band here downside. So here the heavy band is downside, and a hybrid, this is the hybrid stand, like a semi-conservative model. Here is first generation, like here is the first generation of the daughter cells, one from the parent DNA, another from the complementary DNA. Here since own synthesis it will be, here we can observe light band and heavy band, like then also here we can observe these things. So what are the requirements we are here? So requirements like there are a number of requirements deoxyribonucleotides like ATPs, GTPs, DGTPs, DIATPs and DGTPs and DTTPs. Template DNA strands and parent strand and DNA RNA primer enzymes. What are the enzymes required here? DNA polymerase, primase, helicase, guylase. Like gyrase also here we required. Like also here topoisomerase and single strand binding proteins. So first of all, we'll see what are the single strand, what are the functions of the single strand binding proteins. It binds the single strand, it is by single strand binding proteins. It has two functions: the preventing of reaniling. Here we reaniling. This SSBP is preventing of reaniling. Those providing this as a templates and required polymerase and product the DNA nucleus activity. It shows the cooperative bonding. Helicase separate DNA this separate the double stranded DNA. That means here is the unwinding function. Here it is going up for physiological temper. Some anything will be happening here. Like a DNA B is nothing but helicase. Though this is further it is continuing like a DNA B is helicase. So how it will be this whenever it is the DNA binding, it is helicase is entrant. So ultimately the two strands will be unwinding by one and others. So primase and also primer primer is adding DNA ligase and also Okazaki fragments DNA ligase structures. This ligase means adding of small bricks like 3-hydroxyl and superficial coil. So catalyze and all these things, and topoisomerase 1 and topoisomerase 2. The gyrase topoisomerase 2 is nothing but gyrase. DNA polymerase 1, 2, 3. These are the DNA polymerase. DNA polymerase is in what is the functions of DNA polymerase? 5' to 3' direction will be occur. These are the replication. There are the three mechanisms like initiation, elongation, terminations. So steps of replications like unwinding. Also here semi-conservative model. So initiation is unwinding like the DNA polymerase this is DNA polymerase 2 is in marking out the that is helicase and gyrase and these are the requirements. So it's DNA bubble. Elongation is a major process like it is elongation of template strands. Then continuous synthesis and discontinuous synthesis, Okazaki fragments. So replications is the role of replications in eukaryotic cells like a DNA polymerase is different from the what are the inhibitors here? Like inhibitors means prevents the unwinding. Inhibitors of gyrase, those are things. Here is the alpha, beta, gamma DNA polymerase. Telomeres. DNA damage. These are different types of DNA damage and mismatched and base pair existence and nucleotide existence and double strand repairs. So these are the abnormalities of replications like xeroderma pigmentation, ataxia, telangiectasia, hereditary polyposis and colon cancer and phonicone anemia. These xeroderma pigmentations are the autosomal recessive condition. DNA repair is defective due to the lack of thiamine dimers. He is out of radiation. DNA is repair is defective, resulting in the mutant DNA is mediated to the carcinogenic results. So telomeres, these are telomeres is the ending product like a reverse transcriptase. Thank you.